So let's understand the topic, okay? And we'll see the homework questions. So the topic here, they say parents and the functions. So parents and the function are related, they are related. That's what you can understand for now. So let's take the first example, okay, which is the homework question, to see how we can apply the concept to solve that question. So it's a question number -12 to -9 seems like the add 3. What is -12 plus 3? You can check with a calculator. What is -12 plus 3? No, it's not a -15. -12 plus 3 is not a -3. Check with a calculator. -9, thank you. If you take the same -9, you add again 3. -6. The same -6, you add 3. No, the -6, you add the 3, give you -3, and -3, you add the 3, that give you 0. Okay, suppose we want to continue the pattern. So after 0, what do you think we're going to get? No, that's it. You can continue. The pattern, yeah, but tell me what number we're going to get. No, it's not a 1. Exactly, go to positive, yeah, but it will be what, 3? After positive 3, 6, exactly, 9, 12, 15, and so on and so on. Okay, exactly. It's like a number line, but here the unit will have a 3, 3, 3, 3, 3. Okay, now let's trick you, right? So suppose we go backward. That means what? We want to see what number we're gonna have before the -12. Who knows? Thank you, -15. And before -15, -18. Exactly, yeah. So that's the pattern you have to see here. It's going by 5. Yes. So therefore, after 36, we're gonna have 41. Great. And after 41, if you want to continue, 46 and so on. Okay. Okay, understand this. I give you I describe a picture of a function, but let's draw it for you. So see this function like a machine, okay? So the function, we see this as a machine. Okay, when we plug something in and we get something out. What we plug in is X. We plug X in and we get what out? Y out. Okay. Now, what we are plugging in, they also call it input. And what we get out, we call it outcome, or they also call it output. So far, so good. Okay, you also hear keywords like domain, because in the test, they will ask you to find the domain and the range. So I want you to write it down this because they are keywords. Okay, so you can draw that picture, diagram. So we go from left to right. So that's the function. You plug something in, you get something out. This later, f of x, g of x. Or sometimes they'll give some tables and ask you which one is a function. We'll see this also later. But if we take this, okay, they say in the function y is equal to 4x plus 10. Y is equal to 4x plus 10. So that's the function they define, okay? They say if x is -2, remember we say x is the input. X is what you're gonna plug in the function. The function here, we have a 4x plus 10, but the result you get from the input when you plug in is the y. So here they say, what is the value of y? So they want to find the result when the x is -2. So the input here is -2, x is -2, and we want to find the y. But what is y? Y, they say 4x plus 10. What they ask us to do here is to replace x by -2, you work it out and you get the y. So you're gonna say y is equal to 4. Okay, I'm having trouble with this. 4 times, what is the x value? -2 plus 10. Now, without a calculator, what is 4 times -2 plus 10 without a calculator? Perfect. The answer is 2. They say y is 2x. Is 2x, is not 2 times, it's the 2x. Parenthesis, 4 plus x, close, minus 2. They give you x as 3. So what we do here is to replace x by 3 and then do the calculation. Okay, understand that when they say 2x, that means 2 times x. Good? 2 times x. So if you replace y by x by 3, you're going to have a 2. Parenthesis, we times 3 because the x value is 3. Okay, bracket again, we have a 4 plus what? 3. Yes, minus 2. That's what we're going to work out. Okay, so in the parentheses, remember, when you do pandas, in the parentheses, you have a 4 plus 3, right? And 4 plus 3 is what? 7. So we have a, excuse me? Okay, let's see. So we have a 2 times 3 times 7 minus 2. Again, based on pandas, we need to do the multiplication before any subtraction. So the multiplication here, we're going to take 2 times 3. What is 2 times 3? 6. And the 6 times 7, 42. 42 minus 2, 40. Yeah. Okay. Yes, the thing is this, okay? What you have to understand, what you have to understand is this. The first row represent the x value, and the next row represent the y value. So they plug x and they get y. They plug in something and they get something. So this is telling you that if you plug 1, you get 1. The 1 we have here is telling you that if you plug 1 in the function, you get 1 out. Let's check. Replace x by 1. You're going to get 2 times 1, which is 2, minus 1 give you 1. So they are saying that if you plug 2, you get 3, and so on and so on. So therefore, if you plug 12, what you're going to get? So therefore, we do 2 times 12 minus 1. That gives you 24 minus 1. And that gives you, that's 23, you said? Okay. So the y value there is 23. So far, so good. Now, another question. Again, here is to find a pattern. They say how many blocks will be needed, okay, to build the 25th construction in the sequence. 49. Okay. Let's ask you this for people who say B. So, fifth, how many blocks we're going to have in the fifth position? So we're going to have 9. In the sixth blocks, yeah, 11. Okay. So what is the pattern here? So what's the pattern? How we figure out 49? Can you explain the pattern? What is the pattern? For 5, we say 9. For 6, you say 11. Okay. So for 25, okay, you say 49, which is correct. Then can you explain to me what is the pattern here? Or did you check one by one? So the 7th, the 8th, the 9th, to 25th? That's what you did? Wow. That take time. So if they say 100, so you're going to do 1,000, Are you gonna do this to 1,000? Yeah, okay. Result, can you explain to me what's the pattern here? What is the pattern? Okay, so okay, suppose I pick 30. How many blocks are we gonna have in 30? Okay, 30, 29. Thank you. Yes. Okay, that's very good. That's very good. Let's explain what he said. After that, I'm gonna show you another method. But I like his method. Okay, look. Only your position, first method, first position, right? Okay. The first position. Okay, what number you have it below 1? 0. What is 0 plus 1? It's 1. That's why you have a 1 block. It's 1. That's why you have a 1 block. Good? Okay. So, for second position, what number you have below 2? 1. So 2 plus 1, 3. You have 3 blocks. For the third position, what number you have below 3? 2. So 3 plus 2 give you 5. So the position plus the number below that position gives you the number of blocks. Therefore, if you have 25, what number you have below 25 is 24. 25 plus 24 give you the 49. Okay, so if I give a 30, that's why he said 30 plus 29, because 29 is below 30. And if you do the sum, that gives you 59. So suppose they say, okay, 100 construction. How many blocks you're gonna have at 100 construction? 199. So you add the 99 to 100, you get 199. So far, so good. So exactly. So that position, short by 1, you add it together, gives the number of blocks. Okay. Now, another method is this. For each position, I will multiply by 2 and then subtract 1. I multiply by 2, subtract 1. Okay, yes, which is one of the method too. You multiply by 2, you subtract 1. You multiply by 2, you subtract 1. It's similar, that's what they did here. You guys see? Yeah. It's like we are playing game. Yeah, that will help you to. Okay, now let's go to challenge questions. Let's see the pattern here. Okay. Okay, negative 14. Okay, after that, you have negative 8. After that, you have negative 2, and you have a 4. So if you have a negative 14, suppose, you swipe a credit card, okay, for $14. That means you owe your bank $14, right? Okay, and later on, you pay some, and now you don't have $14 to pay, but only $8 to pay. So can you tell me how much you can pay from the 14 to get, the balance as $8 to pay back? 6. So it's like we add the 6 to 14 to get negative 8. If you add another 6 to 8, get negative 2. You add the 6 to negative 2. You add the 6 to 4. Exactly. You get a 10. And if you continue, 16, okay, 22, and so on. So it's like they're adding 6, 6, 6, 6. It's not to the next number, it's the 6th position. Yeah, the 5th position. So this is the first position, the second, the third, the fourth, the 5th, the 6th. The 6th position. Yeah. So it's not to find the next number, it's to find the 6th position. That's why it's very important for yourself math problem to read the instruction. Yeah. Yeah. The 6th position. font here. I don't know if it's better. I don't know. It's worse. Determine if the following relations are functions. Describe the domain and the range. Okay, I want to write this. A relation is a function if, okay, if for every input, that input is the x, so parenthesis x, for every input x, there exists only, I put this in capital, okay, one output y. Let's solve this and let's explain it, and that will help you to solve the next question. The answer here is no, it's not a function. Okay, it's not a function. Let's explain. So in the first bracket, right, we have a 5 comma negative 1. The 5 represents what? The x. And the negative 1 represents the y. Good? Okay, so input 5 has output negative 1. So far, so good. So let's make a table here, please. Okay, I have an x, I have a y. So this will tell me that when x is positive 5, the y is negative 1. So far, so good. Okay, the second we have 0, comma 3. So what is 0? What is 3? What is 0? What is 3? Perfect. After that, we have a negative 2, comma negative 4. What is negative 2? That's the x, and the y is negative 4. After that, we have a 6, comma negative 1. 6 is the x, negative 1 is the y. After that, we have a negative 2 and 3. Okay. Do you see that? When x is negative 2, the y is negative 4. When x is negative 2, the y is 3. So this is not a function because negative 2, x negative 2 has 2 outputs. The negative 2 has negative 4. The same negative 2 has 3. So it's not a function. Because they say a relation is a function for every input x, there exists only one output y. So negative 2 has negative 4. The same negative 2 has 3. So it's not a function. Yes. Yes. They will give you a table and ask you if this is a function. Yeah. So the thing is this, if you see the x value repeating somewhere, it's not a function. Like here, negative 2 is repeating. Yeah, so it's not a function. The y could repeat, no problem. So remember, domain is the same as the input, and range is the output. Okay, so when they say domain here are what? We say input, and that input is the x value. So 5, 0, negative 2, 6. Okay, we don't repeat, the value in the domain. So we have a -2 already, so we don't write again -2. Now, what about the range? Yeah, -1, 3, -4, okay, 3. No, you have 3 already, so yes, that's it. So you have a 5, 0, -2, 6, and the range -1, 3, -4. Exactly, so yes. So no x value here is repeating. So yes, it's a function. Okay, now the domain here will be what? Yes, 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 yes. Thank you. And what about the range? Thank you. So here we want to know if this table represents a function. Okay, and what is the domain and the range? X value will not repeat if it's a function. I want you to write it down, that sentence. X value, the table will not be a function if the X value is repeating. It's just X value. The Y can repeat, no problem. But if the X is repeating, it's a trouble. That means you cannot get the X value twice or 3 times or 4 times, not good. Yeah. It has to be only once. The X value has to be once. So here, is it a function? Yes, no? Yes, it's a function. And what is the domain? Exactly. Wow. Wow. And the range here, exactly. Okay, this is another type of a question you could have. And they want to know if this is a function. Yes, no. It's not just to say yes, no. You have to explain why it's a function, why it's not. Yeah, it's the same. When you have a diagram like this, always the first one is X. And the next one is Y. Always. So it's that. So input, output, input, output, input, output. Yes. So input, output. So this is input, and this is output or outcome. So it's a function. Yes. Dylan is a function. Where is a function? Crystal is a function. Is a function? No. Thank you so much. Thank you so much. Can you explain why it's not a function? Exactly. Exactly. This -1 is related to 7. The same -1 is related to 2. So that means -1 show up twice. Look, -2 is to 7, 0 is to 1, 5 is to 1, -1 to 7, and the -1 again to 2. So we have a -1 show up twice. That's the way you have to, yeah. The one here is still -2, 0, thank you, 5, -1. And the range are 7. Okay, 1, we write it once, and the 2. It's a 2 or -2, -2, yeah. In the list of a domain and a range, you don't write it down numbers 2 times. No, it's just 1, yeah. So far, so good. Okay, let's see another one. What is the first input here? 3, right? That 3 is connected to what number? -9. The same 3 is connected to another number, which is what? 2. That's the way you see that it's repeating. 3 is connected to -9. 3 is also connected to 2. So 3 is repeating. So it's not a function. Okay. And the range, -9. Exactly. No, -1 again. -1. It's not 1, -1. Yeah. Number 6, is it a function? Yes, no? Why? -6. Yeah, negative, because -6 repeating. Yeah, so no. Yeah. And the domain here, we have a -6. We have a 2. So the vertical line test can be used to determine whether a graph represents a function. So before you use that vertical line test, you have to make sure it's a graph they give you. If they give you a table, you cannot use that vertical line test because it's not to use any kind of a line through a table. Table, you check if there is a repeating x value, okay? Or if they give you like a bracket, you know, two values in the bracket like the x and y, again, we check if there is any repeating same number for the x value. Okay, if that's the case, it's not a function. So if we can draw any vertical line that intersects, that means crosses, okay? That intersects a graph more than once. Yeah, more than once. Intersects a graph more than once. Then the graph does not define a function because a function has only one output value for each input value. So a circle is not a function. So it does not define a function. So far, so good. So you just, see this up and down line through the graph. And if any line, okay, crosses more than one time, that means it's not. No, they don't say horizontal line test. Vertical, up and down. Yeah. So yes, it's a function. No, number 8 is not a function. Exactly, it's not a function. Yeah. 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 So if I take the first function they say f of x is equal to 2x minus 5. Guys, understand that. They use that to just to confuse you. What we have here is like they will have a y is equal to 2x minus 5. And now, when x is 3, okay, what will be the y? Yeah. So far, so good. Okay, to make it simple, I can make like a table. I take each one and make it as a table. So if I take f of x, which is my y, which is 2x minus 5. Okay, I draw this table here. So I have an x, I have a y. When x is 3, we say the y is 1. Now, when x is 0, what will be the y? And when x is -2, what will be the y? I'm solving this for x only for now. Okay, let's remove this and this. Okay, so what will be the y value for 0? Is it a 3? Is it a 2? -5. And when it's a -2, what we get? -9. Because we have -2 times 2. Okay, let's write it. You have a 2 parenthesis -2 minus 5. That gives you -4 minus 5, which is -9. So far, so good. We have a y equals, it's a 2x, right? Minus, is it -3, -5, -5? Thank you. Okay, and we have the table like this. We say x, we say y, perfect. So, x, we use 3, 0, -2. 3, 0, -2. For 3, we say 6, 1. For 0, -5. For -2, -9. Now, this time, that's the question. This time, they give the output and ask you to find the input. What I'm gonna do is this. When we have a y is equal to 2x minus 5, we're gonna replace that y here by what? A -11 is equal to 2x minus 5, correct? And we're gonna solve for x. Okay. So we're gonna have -11 plus 5 is equal to 2x. So far, so good. What is -11 plus 5? -6 is equal to 2x divided by 2, and the negative number divided by 2 gives you negative result. So -3 is x. Let's give you another one. Okay, let's take here 6x plus 2. Okay, 6x plus 2. Even they say h of x equals 6x plus 2, and they say that this is same as y equals 6x plus 2. For that, I give you the table. X, y equals 6x plus 2. The question is, okay, complete the table. We have this, this, this. Okay. First of all, I have a -1 here. Okay. I have -2 here. I have a 2 here. Okay. And now, I have a 5 here. Okay. And I have a 3 here. So what you're gonna figure out are the missing values. Let me highlight for you. So this, okay, this, okay, this, okay, okay, and what else? Yeah. So they give you some of the x value, you can figure out the y values. When x is -1, what you got? -4. So here is to replace x by -1 in the function. So you're gonna have y is equal to 6 times -1 plus 2. Based on order of operation, you're gonna do 6 times -1, which is -6, plus 2. That gives you -4. So the yellow is -4. When x is -2, so same thing, you're gonna replace x by -2. We're gonna have y is equal to 6 times -2 plus 2. So negative 12 plus 2 is negative 10. So blue is negative 10. Thank you. Now the first challenge is here. When y is 2, what is the x value? 0. Who got something different? 0, yes, because you replace, this time you're going to replace the y by 2. So you're going to have a 2 is equal to 6x plus 2. Yes, and then now you're going to solve for x. That means what? These two, we're going to subtract. So you have a 0 is equal to 6x. To solve for x, we're going to divide 0 by 6. Exactly. So is 0. So again, you solve that equation. You replace this by 5. So you have a y equals 6x plus 2. You replace y by 5 is equal to 6x plus 2. You're going to do 5 minus 2 is equal to 6x. 3 is equal to 6x. To solve for x, we divide it by 6. Okay. So 3 over 6 is same as 1 over 2 equals x. So in the table here, you're going to have x equals 1 over 2. Yeah. And the last one, yes, 20. So for x equals 3, you have a y equals 6 times 3 plus 2. 18 plus 2 is 20. So far, so good. Wilson, any question? Yeah, instead of taking picture, I think if you write it down, that would be helpful. Okay, when you have a question, based on graph, the first thing to do here is to understand the graph. We have two lines, right? One is a data line and the plan B, and one is strong line, this is a plan A. Now we have these numbers on the horizontal line. These numbers represent what on the horizontal line? Horizontal lines. Minutes of long distance call, minutes. So at bottom here, 100 minutes, 200 minutes, and so on. So the vertical line, the up and down, is the cost on the, so how much you pay. Okay, so the thing is this. When we are using phone or whatever we are electronic device we are using, we want to pay less. That's where you save money. No one wants to pay high because a lot of bills, give you stress, headache, whatever. So when the line is above, it's like the cost is making high. It's going up, the cost is going high. Now for 350, right? 350 minutes. Okay, we have two lines here. So if I draw a line to join the two lines on top, okay, I will touch line A before line B for 350 for question A, right? So when excuse me? Exactly. So if I touch line A, which is plan A, the cost rate to that is less than line B cost. You see? So you pay less for 350 minute call when you use plan A. Cheaper. Plan A is cheaper. It's cheaper for 350. Okay, 20 something. But the other one go to 25. Exactly. So that's why answer for question A is A, plan A. Excuse me, plan A. So far, so good. Now, if you check for 150, again, I draw the same line. This time, I touch plan B first. Yes, so the plan A will be on top. That'll be higher. So, yeah, so plan B is better for question B. So plan B. So here is B. You see? Yeah. So yeah, she got it. That's the. I think that's enough for today. And from today, I hope any kind of a question related to function, yes, you are able to solve it. Correct? Good. Yeah, homework. Again, you're gonna read because I want to cover again something new tomorrow. Quadratic functions. Yes, but we don't have enough time because next week I want to do geometry, so I want to finish everything about this quadratic function. So homework, yes, read. So homework, okay, read page 360. 1 5. Okay. So question 1, question 5. That's what you request, right? 1, 2, 3, 4, 5, and the 33. Okay. So he said 1, 2, 3, 4, 5, and the 33. Yeah. Yeah, let's ask you, who took this before? Do you see question about quadratic equation, like question we have here on page 361, question 33? Do you see question like that when they give you page 361, question 33? Do you see question like that in the test? They say what is the okay, if it does say only, but what is the solution, for they give you equation like but so if you remember upstairs, we were doing questions like that. When I show you how to multiply two numbers, you get this. You added two numbers, you get this. How to solve a quadratic equation. Sometimes we use the quadratic formula. Okay. They ask you to use a quadratic formula. Okay, yeah, the formula, yeah. Negative b plus my square root of, yeah. Okay. Okay. We'll see this tomorrow.